All right, guys, very good morning to all of you, distinguished guests, ladies and gentlemen. My name is Narendra Polishetty, Chief Customer Experience Officer at OrbitShifters. We OrbitShifters extend a sincere welcome to all of you for the second day of India's first virtual AI conference. This event brings together expertise from the industry, academics, and learners. This is an excellent opportunity to discuss and exchange views on existing challenges, further development perspectives in artificial intelligence, as well as to get acquainted with the latest case studies. Let me quickly walk you through today's schedule. We have a guest keynote by Sudha Jamthe, as well as by Prashant Polishetty. Then we have panel discussions on how to handle issues in privacy. Then what is the role of AI in education industry, how AI is impacting healthcare, and also a couple of sessions on nano talk, then job losses and new jobs with AI, bringing AI via NLP, democratizing AI in cricket. So these are the schedules for the morning session. And no conference in the world is complete without the partners. Our partners for the event being automation partner ISA Hyderabad. Then we have magazine partners Industrial Automation, branding partners Skill Monks, then Gold Street, knowledge partners Tara AI, Toggle Now, ULS, and Decrypt AI, along with the best student partners Cult and Supraja. Thank you very much for you guys. And moving on to the particulars of the event, it's a great pleasure for me to introduce our esteemed guest keynote speaker today, Ms. Sudha Jamthe, CEO of IoT Disruptions USA. She's a CSP instructor for IoT, autonomous vehicles, artificial intelligence at Stanford University, USA. A technology futurist with business operation experience, shaping early technology ecosystems by educating and mentoring business professionals to build a connected, autonomous, driverless world in their companies or by pivoting their careers. She's the author of 3 IoT books, 1 book about self-driving cars, keynote speakers, board or advisor for digital mobility. She's looking to build a federal AI solution or solve problems using data-driven business models via global capstone projects at Driverless World School. I welcome Ms. Sudha Jamthe to address the audience.
Hello, everybody. Good morning. This is exciting for me to listen in yesterday to know how hungry everybody is, what you're looking for. So I had to go and adapt my slide deck today. So I hope we will have a interactive conversation, because my teaching style is not to come and, I've got some slides to guide you or guide my thinking on the process of what I want to share, but we will get more out of this only when, we keep it interactive. So feel free to type in the chat, ask a question or comment. And even if you disagree with me, I think it's a pleasure, because we are all going to come at it from various perspectives. So my motivation to be here is, obviously, I was very excited to hear about this whole conference from Prashant and Mahesh, and wanted to get a sneak peek. But I hope I learned something from you by the end of this session. I always do. You will, as a student, when you think about it, when you go into a conference, you're thinking you're there to learn. But I think learning is a collective experience, and it's all the more important when we do this online. It becomes a learning, a collaborative exercise. Okay.
Kudos, Sudha. Kudos.
Thank you. So my screen is being shared or not shared?
Not yet, Sudha.
Not yet. Okay. So one thing I want to show. So here we go. So you're seeing my slides? Yeah?
Yes.
Okay. I see that. Okay. So I'm going to be talking to you about how to do a career pivot to artificial intelligence. And I remember yesterday in the very first presentation was about reskilling. And one thing that stuck me was the difference between skilling, as in learning something, and reskilling, where you already know something, you've learned something in college, or maybe you're in some stage of your career, and then you want to learn something new. Especially with artificial intelligence, I heard that 8th graders in CBSE are learning AI in India. So if you're not one of those 8th graders, and I'm going by the audience, I'm assuming that you finished 8th grade so long ago. So you're going to be reskilling and learning. So that is going to take a different kind of mindset. So the way I'm going to structure my conversation, you already heard, and you heard a very long version of my bio, so I'm going to skip this. And I wanted to start with getting us to the same page on artificial intelligence, because we've been talking about AI. AI means many different things for many people. So can you tell me what is your favorite AI? It can be a thing, it can be an IoT, it can be an invisible AI. What is your favorite AI? I'll get to see the chat here, right?
Yes, you can.
Okay. Does anybody want to volunteer and tell me their favorite AI?
I think one mentioned, Revant mentioned driverless cars. Vijaya
Okay.
mentioned IoT. Anirudh mentioned Siri.
Okay.
Nitish mentioned Google Assistant.
Yeah.
I would say every banking company, because they talk about fraud prevention, and pretty much all of that is done by the artificial intelligence software.
So all our banking, all our credit card is always looking for anomalies in our behavior, right? Do we withdraw this amount of money, or suddenly does it look bigger? Or is there a different location? So every time I come to India, my bank thinks that somebody stole my credit card. And so if
absolutely without a notification,
right, because they're tracking for location and they're saying this is an anomaly from my normal behavior. So banking is one. A lot of chatbots, a lot of voice assistants, and self-driving car too. So I'm happy to hear that, because that's my favorite. So that was not a plug, but that is my favorite AI. So I'm going to show you that. And there is a quiz at the end of this. Not immediately after this, but I want you to watch this. Okay, I'm not kidding. Okay, so if I switch to any screen, am I going to be, you're able to see the screen? Yeah, okay, good. So I'm going to try and show you a video, and I have a habit of chasing self-driving cars. I have this obsessive compulsive need to go hug robots. I'm not kidding. I mean, if you got a very glorified introduction to me, this is, now you're going to see the real me. So I chase self-driving cars because essentially all of us in the road are training data for the self-driving car. So watch this for a minute, okay? Autonomous vehicles promise to make our roads safe. In reality, they bring connected and electric vehicles, which changes urban mobility as we know it. I'm Sudha Jamthe. I teach IoT and autonomous vehicle business at Stanford Continuing Studies. As a technology futurist, I research artificial intelligence and autonomous vehicle space and enjoy mentoring business professionals build the driverless world. To truly understand autonomous vehicle business, you need to learn 3 core topics. One is autonomous vehicle data. What data is collected in the car? What are the 3 digital twins in the car? And how do you create business value from this data? The second topic is autonomous vehicle business models. Who's going to pay for this car? It's the consumer ownership model, which the consumers your industry, come learn the business model. The third topic is autonomous vehicle product management. When you think of autonomous vehicle car cognition, it is artificial intelligence, machine learning based product. And the entire tech stack, our phone, is going to switch to the car. What is needed to understand customer behavior and go translate this into customer experience so that you build the product? Okay, so I'm going to get out of the screen. I'm going to go back to my deck. Okay, So that's my favorite AI, as I promised. And I'm not going to ask you the quiz right away. So I want us to get to a common starting point of what is AI, right? So there could be, like from the examples you gave, it could be doing some kind of text to speech or speech to text, like the virtual assistants are doing. It could be doing natural language processing, which also the Siris of the world are doing, right? And or it could be just crunching through a bunch of data and looking for, organizing it and looking for some patterns, which is basic machine learning, like the banking example we saw. So the example of self-driving car is going to be looking at object identification, identifying what's objects on the road, to separate out traffic, to look at the lanes, to look at any obstruction that's coming in the road. There's a lot of image computer vision based processing that's happening on the road. So I'm not going to go into the autonomous vehicle per se, but basic, when I keep talking about AI for rest of this talk today, I am going to think about machine learning, because at a fundamental level, all AI, what it is doing is it is taking a large volume of data and it's trying to figure out a geometric pattern. So one of the things I heard yesterday when you were asking questions about what should you learn? Should you learn Python? Should you learn C++? What are we going to learn? And how important is mathematics in all this? And I heard about how linear algebra is important. So we're going to get to that in a minute, but the whole concept of AI, whether you build the algorithm or you're going to be calling an API that somebody has built, underlying machine learning is all about taking huge volume of data and it is looking for a pattern. In this case, you can see two concentric circle, and I'm tempted to ask you a formula for a circle, so I'm going to skip that. But it's basically, once it forms a circle or it forms a pattern, in linear algebra, it can actually fit it into a line. And so based on that, it can make decisions. Okay, so I believe we are in sync on this. I want you to pause and ask me any questions or comment or say anything, because I'm going to assume, since we're all talking about AI, we've been talking about models and algorithms, we are in agreement on this common basis that you feed training data and you're going to make the algorithm look for some linear algebra pattern, and based on that it is going to do a fit and you're going to get a decision. Yeah, because since I'm not meeting you all in person and I'm not hearing voices, I don't want to assume you know something, and I don't want to kind of over explain something that's too basic. So help me out here. Okay, so now that's established, so we know that you get data and you feed it and it is going to make decisions, right? So I'm going to play with a real AI right here. You see this here on the screen? So this is from Google, and if you see, it's called quickdraw.withgoogle.com, and with Google they have a lot of fun different AI that you can play with. So here is a doodling neural network, and I'm going to play with it, right? I'm going to draw. Okay. So it says draw teddy bear, and I'm doing this live. This is not set up, okay? Draw a lousy teddy bear. Oh.
I see rainbow, or circle, or moon. I see snowman, or mushroom, or hamburger, or toilet. I see penguin. Oh, I know, it's teddy bear.
Whoa. Okay.
I see banana, or garden hose, or mustache, or shoe. I see leaf, or whale, or fish, or mouse, or steak. I see eye. Sorry, I couldn't get it.
Okay, I'm going to skip through this. When it says a blackberry,
I see circle. I see blueberry, or moon, or potato.
Okay, you'll have to bear with me because it will make me draw 5 of these. So this is the third one, right? And it says, sorry.
Sorry, I couldn't get it.
Okay. I'm going to kind of...
I see circle, or keyboard, or bow tie, or panda. I see heart, or eyeglasses, or bird, or blueberry. I see teapot, or bear, or owl. I see eagle, or dove, or cookie, or mouse. Oh, I know, it's sheep.
From a cookie, it went all the way to a sheep. Cooler.
I see pond, or sleeping bag, or pool, or cup. I see paint can.
No, it's okay. I need to draw cooler. Okay, this is the fifth one, guys. So it was live trying to guess what I was drawing. It's a neural network.
Sorry, I couldn't get it.
Okay, I should.
I see magic wand. Oh, I know, it's octagon.
Ooh, look at that. Okay, so I just want to pick one of them. So what it is doing is, here I drew a teddy bear, which is, as a human, you could potentially guess it. Here I did a sheep, maybe yes. I'm not sure, even I would think this is cooler. And here I didn't even finish drawing this and it said the right answer. I think I didn't do a good job with a shark. But how did it work? So it actually, I want to show you one of them. So what it did, we asked it to draw a teddy bear. And as I was drawing, it was trying to go back to its training data and it was trying to guess. And it always started with a circle because most of these I did with a circle. And if you look at, the correct answer is teddy bear. And it initially thought it was a bear. At some point it thought it was a backpack. So these are the three closest match it got. And this is how it has training data fed to teach it. Oh, this is a nice teddy bear. See this one in the middle? They've done a nice job. This is all the different examples of teddy bear that it has in its training data, based on which it tried to recognize my teddy bear. So I'm going to get out of this screen back again to myself. Okay. So what did we learn from this? What did we learn from here? So I have a question for you. Is this AI learning? You know what they say, you feed training data and you create a model and you run it and then it's learning, right? Each time you are giving more training, you're giving more real data to it, it's guessing, but AI can learn. Is this AI learning, yes or no? Prashant, you'll have to read out the answer. Narendra said something. I can't see the chat here. Yes, I see the chat. I see a lot of yes. Okay. So here's the catch. One is the AI is a learning AI. I agree. But when Google launched this, they must have fed some training data and then put it out for people like us to go play with it. When I'm actually running it, it's an inference model, right? It's like a piece of software. They didn't build it rule-based, but they built it using training data. That inference model is what I'm interacting with, and it's making a decision, which is basically matching the pattern to see what it is. And it says, yes, that's a teddy bear. Oh, it looks like a potato. It was guessing till finally it guessed the teddy bear somehow, right? And at that point, it is not learning. At that point, it is actually running the model and it is actually making a decision. And it is saying it's a potato, it's whatever, right? At that point, it is just running. And later, Google must have collected my teddy bear, my shark, all the images I drew. And it said, okay, now we've got user data and they will go and train the algorithm back, right? So that is, if you're thinking about it as basic software, it is like you wrote a piece of software, you got user input, and now you're refining that to improve and build that better. And it's the same concept, but in this case, it is the AI. So it is a learning AI, which means it's capable of learning, but it is not learning live. So why this is important is in self-driving cars, when the examples you saw, the car is driving autonomously. So the very first one you saw was a Google car. And then there was one where there was a turn like that. That was a Apple car. And I think I showed a Toyota Research Labs car. I even showed like a bot in the end, which is a delivery bot called KiwiBot. All of them are running autonomously, which means all of them have a training data fed to create inference model. In fact, in autonomous vehicle, it's not just one inference model, it's a system of system, and it is running autonomously with a piece of software which is sitting in the device, right, which is the car. And then when I am chasing it, I'm trying to go by its side, or somebody else is crossing it. All that is new training data. And then it's collecting all the training data. It's not doing anything. It cannot learn. Suppose I cut it in a certain way and it was surprised and it was not ready for it. The next time it runs within the same trip, it is not going to do any better because its model has not been updated. So that is where all the data is getting collected. And then the next time the engineers run it that night and build the next version of the software is where it is going to get smarter. And in fact, with the way I was drawing, I'm going to make it less smarter because some of my drawings were really horrible. My octagon was not even an octagon, but it guessed it. So sometimes, the concept of training data from live customers might actually take it one step back. So if you remember in my initial introduction, you heard about how I like to build federated AI, and I'm looking to partner with people to build federated AI. Federated AI is a concept where you can build a distributed machine learning. So when I'm feeding training data and I build the inference model, and then there's a piece of software, right, that's sitting with me. Every company could do that. And they protect their data. You don't see what training data they used. And then they have the inference model. So when banks want to collaborate with each other, to the example that Prashant said at the start, when banks want to work with each other and they want to improve their model, they will have, each of them will have their own fraud models. What if they could all share their fraud models? So a distributed machine learning model, which is federated AI, what it would do is it will allow them to share their machine learning model without exposing their underlying data, so they don't expose their privacy of their customer data. In fact, I think you're going to have a session on privacy coming up right after Prashant's talk. So I hope you will think about how you are going to protect the customer data when you're building the model or sharing information. But that's the federation model that I would like to do that in a car setting. I see a question. What is this question? Can somebody read this for me? Being a student from, it's just jumping off. Saurabh, let me check.
You were saying being a student, where will he get or collect the data so that his machine learning or machine can perform better?
Okay, that's a good question. So, so I will come back to that. There is a lot of, if you're going to just learn to build a model, there is a lot of open data set. In fact, the Waymo car that you saw, if you go to Waymo Open Challenge, there's a lot of open data that Waymo has put out. A lot of self-driving car companies have created trained data with labeled data that you can just play with and try and build a model. But it would be kind of theoretical model. You don't have a self-driving car, but you could potentially create an autonomous vehicle that could run with that model. And the same thing with, the Google is saying, okay, here's open draw, the quick draw. They're going to have the inference model. So there is training data. Basically, when you say data, it could be sound, it could be images, it could be anything, right? So there's a lot of free data sets available. So if you are looking to do image-based, the biggest database for that is ImageNet. So basically, you can classify images and you can play with it to build a model. That's the most common one for ImageNet for images. If you're looking to understand traffic signs, there's a lot on GitHub. I'm happy to actually follow up and give you more resources if you're interested, okay? So I want to go back. There was one more question. Okay, so Mahesh is saying let's take the questions in the end. Okay, so the one lesson with this is that the AI is not perfect. So it did not find all the right fit for me when I was trying to draw. If instead of it was just fun and drawing, what it was something serious, what it was checking whether, they're looking at a blood sample or a swab and they're checking whether, somebody has COVID. There are going to be false positive and false negative. It is, in a self-driving car, there have been accidents, unfortunately, based on not understanding the object. There was this unfortunate case of an Uber accident where a person, so they were training with a person crossing the road, but this person turned out to be crossing with a bicycle. So they were not driving a bicycle. They were ready to, if somebody cut in with a bicycle, they were ready to train and trained it if somebody walked and, you know, like jaywalking on the street. But here was a person who was pushing his bike and was crossing the road. And he had some kind of bag, so it kind of, you know, messed up the shape of the bike for the car to see. So the car hit that person. So AI can make mistakes and will make mistakes. So when you're building something, you need to be aware of the responsibility you're taking. So yesterday, I think there was a session about explainable AI. That was about how to make it transparent on what does the AI know. But if you're having a deep neural network of many, many layers, it is impossible to track back and see how in its brain did it guess. So this question in that octagon that you drew, we can say that the AI wouldn't have had a lesser chance to recognize unfinished drawing if you started the drawing from a different point of view. That's right. So it is trying to guess at every stage, and somehow even before I finished the octagon, it had identified the octagon. So if I had started out on the right side, if I had drawn the top line and the bottom line and the right, left and right lines, it would have arrived at it eventually within the 20 seconds, whatever I gave as my final product, it would have done a match. It kept on matching and it arrived at that solution. So yes, it is possible if I drew it differently, it would have kind of been thrown off. But the end product is what it matched in the end. So it did work. So the other thing, I love this question because if it had been fed a drawing which was an incomplete hexagon, exactly like what I had given it, then 100% it will fit it and it will say it will find the right answer. So that is called overfitting. So when you give your training data, if you give what you gave in your training data, it has already learned it. So if it sees the exact same thing, then it is going to fit it and then it is going to find the answer. So that doesn't help in decision making because it's really not learning. It's like cheating. It's to, instead of studying for an exam and understanding a concept and being able to answer any question, if you had trained for 100 questions from a question bank and one of those questions showed up and you knew exactly to solve for it, you're really not built knowledge. So that's what happens when overfitting happens. And so you have to keep a balance on when you have data. Somebody asked, where do you get the data? So when you are looking at getting data, you have to take the data that you have, and then you have to keep some for training, and then you have to keep some for testing whether your model worked. And then you actually feed the live data to see whether the model is making decisions right. So the important lesson here is the AI can and will make mistakes. So in a business setting, it is very important. So if it is not understanding my bank, whether I'm making a transaction. So I had this situation where I went and tried to withdraw money, and my bank had changed this nice interface, and they said, what denominations do you want? Do you want it in hundreds and 50s? And I wanted it in 20s. So when I tried to tap on the screen, it didn't work. And so I tried it again. So I canceled the transaction. I tried it again. And then it didn't work. Then I saw the lady next to me in the next ATM seemed to be working. So I got off that ATM and I went to the next ATM. And it was a classic case where it was looking for anomalies and said, she has tried 2 times, her transaction didn't go through. Now she's moved to a different ATM. She's definitely some thief who's got the card, and they locked my account. And so even if you're looking for, feeding the data and training it, it cannot be just one spike in data. So you have to have metrics that define what you're looking for. Am I looking for a pattern of making transactions in multiple ATMs at the same time within a short window of time? Am I looking for a certain denomination of withdrawals? Am I looking for some different location that this person never showed up? Am I looking for a combination of it? So in a real business setting, it is never so raw, like you give this training data and the AI makes this decision and it says here is an octagon. It is going to be based on what you're looking for, what you're solving for. And so you have to have a multiple set of metrics. So personally, I come from a background where I've built products and in product management, and then I moved to analytics. It's more focused on business intelligence to optimize the metrics to figure out what will create better growth. And so figuring out the right metrics, instrumenting the metrics becomes important skill. And I'm specifically saying that when we are talking about what is AI, how does AI work, and that AI can create false positive and false negative, because finally AI is there to solve a problem, right? So you can create a model and you can make it theoretically run, but it is going to solve a problem. Okay, so let us move on. I have a question for you. So I'm going to show you two different AI markets. So when you define working in AI space, because remember, I promised this topic is about pivoting your career, right? So if you're going to work in the AI market, I'm going to show you two different market options. Tell me which market would you rather work in? There is a $100 trillion AI market or a $14 trillion AI market. By definition, saying by 2020, we will hit this number according to two different sources. Which market would you like to work in? Give me an answer. 14. Whoa, you guys really surprised me. Now I'm saying 100 trillion. So I expected most people to say 100 trillion. Now the 100 trillion answers are coming. And a couple people said 14 trillion. I would like to know how they are thinking, what is the reasoning, but since we don't have too much time, I'm not going to get to the answer. So the two kind of markets where, what is 100 trillion and what is 14 trillion AI market it's not a made up thing. There is a $100 trillion AI market. Remember yesterday when we got started, I think Dr. Srinivas said this, one of the, you can be excited about building an algorithm and want to be a data scientist and do research and say, okay, I'm going to be good at data science and I'm going to learn Python and I'm good at linear algebra, I'm going to go build models. But he was suggesting becoming a researcher is a much longer commitment, and it is better if you start building real products. And so go focus on building products, and then if you prefer to focus more on building algorithms, refining algorithms, then you can go that route. So why am I saying that here now? Because the two markets that I'm talking about, the $100 trillion and the $14 trillion, both exist in AI. The $100 trillion market is the AI software market. So when you hear about there is an algorithm for building a voice algorithm from Alexa, or the tech companies who are building the autonomous vehicle stack, and they're saying, okay, we have the AV technology and we are just going to make it available for other car companies. Like that, in every industry, there are a lot of companies that are building AI as a piece of software. So they remember what we said about training data. They are feeding training data. They're using linear algebra, building a model, and they are making it available as a piece of software. So how do you access it? As an API. And that is the software market. So Google and all the big companies are there. There are many startups who are very specialized in it. I know a startup, AI startup out of Delhi, who basically said, okay, we are going to look at images, and they do computer vision. And they said, look at images in WhatsApp, and we can decide which of the photos you should keep, which of them you should purge to clean up. And they just decided that they will build an AI on that, and they did a fantastic job. But it's a very specialized algorithm that they built. So anything that you build, companies are offering as a piece of software is a $100 trillion business. And applying that, taking that and applying that in different industry, it could be precision agriculture with IoT sensor data, or it could be in healthcare looking at identifying a disease, or it could be banking looking for anomalies. So all of that comes to the application side. So whether you're going to be building the AI algorithm as a software that is available as a platform or AI, or whether you're going to apply that as a business application, is the two industry. Ideally, applying, so this is like the businesses are going to be customers for companies who are software companies, AI software companies. But why would this number be so much smaller? It is because it has to go through a longer cycle. It's easy to create a piece of software and say, I've got it here, and somebody buy it from me. But applying that to real customer data, making it work, is much harder. So remember I said, I'm going to ask you a quiz right when you got started. When you watched that video about autonomous vehicle business and autonomous vehicle, do you remember 3 areas that I said we should focus on in building an AI? And think about, I said that specifically for autonomous vehicle, but applies to everything else. So tell me if you remember any of these. What were the 3 areas? Yeah, Lita, awesome, thank you. So that's my favorite answer. So I'm okay to, make you skip that. Thank you. So one is, this is the Apple car that you saw, which kind of went and did a curve. So one is actually taking the data and modeling it, mapping it to the algorithm to make the algorithm work fit for the data, right? So that is the first piece. The second piece is actually business model for the business, who's going to pay for it. I'm not going to cover that as part of this conversation. And the third piece is the design of the UI, right? What is going to be the human interface when the UI interfaces with you? It could be invisible, like a search engine. It just gets you the answer, or a spam filter. It does its job and you never see spam. Or it could have an interface like the examples that you gave. All of them had some kind of interface. So all those 3 are important to learn, right? But when you build an AI product versus a solution, what is the difference? The difference is you're going to take algorithm, you're going to map it to the data, and you're going to create the model. So if you just build a piece of software, you can take your own training data and say, I've got this system going. So fundamentally, all algorithms, whatever algorithms in whatever industry, whether it is a CNN, whether it is machine learning, anything, finally it is looking for patterns. It's going to do these 4 things. So it's going to group or segment data. It's going to make some predictions. And it could be predicting whether a part will fail. Or it could be a recommendation or like a personalization and say, okay, you bought this, now do you want to buy these other items? And other thing I already said is the anomaly, which is the banking example that we saw. So fundamentally, it is going to do these 4 things. So I have one more quiz for you, and I've asked you to answer more things than I answered. So in this picture, if this is my data, a picture, right? What is it training for? Tell me what you can use this data to train a model. What is it training for? Supply chain. Okay, that's interesting, Usha. Identify a fruit. Yes, maybe you're getting a robot to pick oranges, and it needs to see what an orange looks like. Fruit with a leaf. Yeah, a lot of fruits. Other than fruit, can this be used? Yes.
Sudha, sorry to interrupt. We might have to wrap the session a little early because we are already into 17 minutes for the next session. So sorry.
Okay. Yeah, no problem. Yeah. So
thank you.
Okay, no problem. So the other thing is, yes, round object, hands, yes, shadow, perfect. And sky, what about the sky? Maybe it's looking for climate. So training data is a very, very important piece of what you would be doing. So with that, I want to go to, I had some slides saying who works in AI, and everybody works in AI. In the company, in one research, everybody seems to be working in AI. So when you pivot to AI, I had a bunch of slides, and I'm going to share this because I was just getting prepared based on what you would give us, ask your questions, right? So we spoke about the, AI software application market. Algorithms do 4 things, and you offer training data, and you have to instrument this, talk about partnerships. So where are the hottest jobs? There's design jobs, ecosystem jobs, simulation, data science, product management, whole bunch of things, right? So my last piece of information is when you pivot to AI, right? I would recommend just start with one area you're passionate about. And I think Prashant spoke about passion as one of the skills when we were talking about the reskilling panel yesterday, that you could get excited about just data. And like, I'm very excited about data more than the algorithm. Or you could be looking at computer vision, or, looking at, sound and voice data. And so pick an area that you feel excited about. Or it could be an industry, and you say, I come from banking industry, or I'm excited in retail. Pick an industry or a technology, okay? And then learn that. 4 steps I would say is learn that and figure out what are the applications. Sorry, this is getting cut off here, right? You're not seeing the screen. Yeah. So learn a technology and then really go deeper and become an expert, become obsessed. I love self-driving cars. I chase them. I see every possible self-driving car and I want to see how they would behave in different situations. I go deeper into it. I look at the car cognition technology on one end. I look at the data in the car. I look at how it interacts with me. So try and think about who's doing what are the gaps, and where you could potentially contribute. And then you need to go hands-on. Somebody was asking about data. In fact, even for self-driving car, there is a lot of data. There is a Udacity GitHub where you will actually see the models you can run, and you can build a project. That would obviously have something to showcase, but it will also give you confidence. So with that, I'm going to wrap up, and I need to stop sharing my screen. So I have a site called Driverless World School where I do this career pivot webinars. So if you want to join that, they're free. But I have a bunch of other resources and videos that I'm going to put it out there under the career pivot. So if you want to come and look at it, there is resources by which you can learn. And I'm also going to share this deck with Prashant, and you'll be able to get access to that. So with that, I hope you learn something new, and I will I'll be happy to connect online. And if you want to connect with me on LinkedIn, and if you have any follow-up questions that you're burning to ask but you could not, I would love to, I would love to give you pointers or guidance and follow up. And definitely, I never heard anybody say shadow was something they were like training for. So that's a very interesting training data answer that you gave. So thank you for that. So with that, I'm going to wrap up. Thank you so much, and enjoy the rest of the conference. Thanks. Bye.
Thank you very much, Sudha. That was a really fantastic presentation. In fact, a lot of learnings, and probably some people have some new way of looking at the same picture. Thank you very much for that.
Thank you. Thank you, Mike.
Guys, now moving on to the next guest keynote. We have Prashant Polishetty. He's the co-founder and CEO of OrbitShifters Incorporation, USA.